So we are going to now go ahead and continue our studies of polygons, but this time, instead of polygons in general, we're going to look at polygon specific kinds. And we're going to start with quadrilaterals. So we're going to spend the last part of this chapter, a big part of it, on quadrilaterals. And we're going to start specifically with parallelograms today. We're going to take and look at what makes a quadrilateral a parallelogram. Some tongue twisters there. So first of all, the definition is just a quadrilateral with both pairs of opposite sides parallel. So this side is parallel to this side, and this side is parallel to this side. Okay, so in this case, we have AB parallel to CD and AC parallel to BD. All right, so that's the basic definition of a parallelogram. We also have several theorems about a parallelogram. So the first theorem that we have is that if a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent. So in this case, then, we're going to have AB congruent to CD and AC congruent to BD. So now we can mark these congruent. So this side's congruent to this side's congruent to that. Okay. Now another theorem, if a quadrilateral is a parallelogram, the consecutive angles are supplementary. Remember, consecutive angles mean next to each other. So A and B are consecutive angles. So basically, the measure of angle A plus the measure of angle B is 180 degrees. And I can just go right around the parallelogram. The measure of angle D plus the measure of angle B equals 180 degrees. D plus C is 180, and C plus A is 180. And by the way, we can abbreviate a parallelogram. Okay, we use a parallelogram symbol, and then we use the 4 letters of that parallelogram, A, B, C, D, and it has to go in order, either clockwise or counterclockwise. So we could also say, if we started at B and went the other way, B, A, C, D. And that's a convention, a naming convention, much like angles and the other things that we've looked at. Okay. Another theorem that we have is if a quadrilateral is a parallelogram, then opposite angles are congruent. So opposite angles are going to be like angle C and angle B. So this is going to be congruent to that. So angle B is congruent to angle C, and angle A is congruent to angle D. So those are some parallelogram theorems. There's a lot of theorems in this chapter for you guys to know, or definitions. So what I want to do is I want to prove that last theorem, that if a quadrilateral is a parallelogram, then opposite angles are congruent. And I'm just going to make it a little easier for you guys to follow, I'm going to name those angles. Angle 1 and angle 2, angle 3, and angle 4. So I'm going to start with my given. I've got a parallelogram ABCD, and since it's a parallelogram, I know that AB is parallel to CD, and I know that AC is parallel to BD. So I know that those things are true. Okay. And that is by the definition of a parallelogram. So now, and there are many ways to do this. In fact, I'm going to show you after this a really simple way to prove this. But now, I'm saying that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. And that's by the alternate interior angle postulate. So if two lines are parallel, their alternate interior angles are congruent. Okay. Then I'm just going to state that the measures of those angles are equal. Measure of angle 1 equals measure of angle 4. This should be measure of angle 2 is equal to the measure of angle 3. Okay? And that's just by definition of congruence. It's a formality for what we're going to do. Then I'm going to say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4 plus the measure of angle 3. And I think I wrote substitution down here, and that's actually not the right answer. This would be addition of equality. I'm adding the same thing to both sides, so I'm adding that and that. It's the same thing because their measures are the same. Okay. Then I'm saying that this angle 1 here plus the measure of angle 2 is the measure of angle ABD. The measure of angle 3, or measure of angle 4, plus the measure of angle 3 is equal to ACD. And that's way, way from the beginning of the year, angle addition postulate. I'm then going to say that those are congruent. So I'm going to take this ABD and I'm going to sub it in up here for the measure of angle 1 plus the measure of angle 2. ACD I'm going to sub in for measure of angle 4 plus the measure of angle 3, and we could either use substitution or transitive. It doesn't really matter. And now I've said that ABD is congruent to ACD by definition of congruence. So those are opposite angles, and it was definitely the tough route that I took to solve this. So that angle and that angle are opposite. And I'm going to show you an easier way to prove that using some of the other theorems that we know. All right, so if I've got a parallelogram, I want to prove that opposite sides are congruent. And this time I'm going to write it in. Okay, so if I've got given parallelogram A, B, C, D, this time I'm going to take the easy route and I'm going to prove A is congruent to D. All right, so I'm going to start with my given, which is parallelogram A, B, C, D is a parallelogram, basically, duh, and that's given. Now I'm going to say that my sides opposite are congruent. So AB is congruent to CD, and AC is congruent to BD, or DB, doesn't matter the order. And that's because opposite sides of a parallelogram, and we can abbreviate, are congruent. And that was the very first theorem I gave you. All right. So I'm saying that this is congruent to this, and this is congruent to this. Hopefully you guys know where I'm going. Okay. I can then say that BC is congruent to CB, and that would be by reflexive. All right. And then we can say that our triangles are congruent. So triangle ABC is congruent to triangle DCA by side, side, side. And if you didn't know where you're going, I surely hope you know where I'm going now. Angle A is congruent to angle D by our favorite theorem, CPCTC. Okay, so there's an easier way to prove it. The first one, I proved it without knowing any of my parallelogram theorems, any of the new theorems. So I just solved it using angle addition and parallel lines. Here I've used one of the theorems that we already know. Okay. I got another theorem for you, and that is if a quadrilateral is a parallelogram, then their diagonals bisect each other. So remember, HJ is a diagonal, and IK is a diagonal. So if they bisect each other, and we'll say that that's our midpoint, because they bisect each other, meaning that this should be congruent to this, and this should be congruent to this. Okay? They aren't necessarily congruent to each other, they just are congruent where they bisect. So I'm going to set up some equations here to find the values of A and B. So since they bisect, I know that A is equal to 2B minus 8, and then I know that B is equal to A plus 2. So A is equal to the 2B minus 8, and then this is congruent to this. So all I'm going to do is I'm going to use a system, because I've got A's and B's, and I'm going to sub that in for the B right there. So I'm going to get A equals 2 times A plus 2 minus 8. And you guys know this is usually where I screw up, is my arithmetic. So A equals 2A plus 4 distributing minus 8. A equals 2A minus 4. If I subtract 2A from both sides, I'm going to get negative A equals negative 4, and then that would mean that A is just 4. So now that I know what A is, all I have to do is substitute that into the B equals A plus 2. So B equals 4 plus 2, or B equals 6. Okay, so that's all they asked me for, was those values. But remember, we could plug it back in to see if it works. If I were to put A 4 in there, excuse me. Okay, so that side here would be 4. And over here, this would be 12 minus 8, which is also 4. Here, my B is 6. And if I were to put 4 in here, 4 plus 2 is also 6. So you can check your work. I know some of you like to be perfect, which is great. Okay, one more theorem says that if 3 or more parallel lines cut off congruent segments on one circle, then they cut off congruent segments on every transversal. So I've got this transversal, which is AC, is my transversal. Okay, I've got parallel lines AB parallel to CD, which in turn is parallel to EF. So all of those are parallel. I've got AC, according to this drawing, congruent to CE. Okay, so since I know on that transversal those are congruent, that means on this transversal, those segments are also going to be congruent. So by this theorem, we know that BD is congruent to DF as well. So just another theorem within that chapter. Pretty quick little lesson compared to last night's. So what do you know about parallelograms? Instead of what are we going to learn? Well, we know that their opposite sides are congruent by definition. Or I'm sorry, are parallel by definition. Okay, we know that their opposite sides are congruent by that first theorem. We know that opposite angles are congruent, and we proved it both ways. And then we know that consecutive angles are supplementary or add up to 180. So you guys have a great evening, and I will see you in school tomorrow, hopefully.